innovation. And the automotive industry is fascinating. They've adopted a lot of new technologies, and the way that it's changed over the last 20, 30 years is a major step change in terms of efficiency and sort of the product quality that they're sort of driving out now. Now, there are issues, obviously, in it, like any sector of the likes of VW, it's an absolute nightmare that's gone on there. But there are a lot of interesting concepts and ideas. Now, driverless cars themselves are amazing, because why is one of the most powerful companies in the world, in the form of Google, who's got no relation to the automotive sector, so interested in this? And it's all to do with driverless cars. Now, driverless cars are suddenly very safe. You can just get in one, you can go to work, you can have a sleep in the car, you can do your work in the car. Who would buy one? Would you put your hand up if you'd buy a driverless car? Now, the point is, you won't be able to buy a driverless car because it'll work in exactly the same way as Uber does, where it'll be sold as a service. And that's because the utilisation of a private vehicle is about 3 to 5%. Now, when it's done in a service model and it's sold as a service and actually people don't own it, then you'll see that utilisation jump to about 70%. Now, if we take that idea and say, well, utilisation is important because in terms of our usage of our capital, it's very key to the bottom line, then on a food manufacturing line, what does the utilisation look like of some of our key technologies? I want to just take that idea, because we'll come back onto it later. Now, so in terms of what OAL do, we do sort of design automation of food processing systems. So taking raw ingredients, converting them, heating them, mixing them, and take them into raw materials. And that's a very sort of traditional way that a factory would be laid out. So you've got the ingredient loading areas, you've then got the low care cooking areas, which then taking it through to filling and then into packaging. And it's really in that processing area that we operate. Working with some of the big names in the UK to do soups, sauces. We also work on the dry materials and bakeries. And what's really critical is to all these companies, because it's a very competitive industry, as you all know, that it's about really minimising costs. And when we say costs, we don't just mean the bottom line in terms of profitability and the operational efficiency, but the cost of quality. Because if you don't have the best quality product, consumers will move to different alternatives. And at the same time, there's also major costs associated to sustainability, and you can start to see those changes coming in the way companies start to act in the market differently. So because of this, and this is the market we're operating in, we want to be different, we want to innovate. Now, innovation is something that everyone likes to say, yeah, we innovate, but how much are they really doing it? Now, as a company, we're putting 8.2% of our own revenue back into innovation. And to put it into perspective, that's more than Apple, and it's a lot more than other SMEs in sort of this area. And the big way that we're doing this is through Innovate UK Projects. So we're in this Nutrition for Life project, where the call was to improve the safety and the health benefits of food products. And we're working with the University of Lincoln and Bakkavor on our new steam infusion technology, which is about heating and mixing ingredients in a type of steam injection that's actually much more advanced, because we're accelerating the steam to 1,000 metres a second. Now, that profound environment, then it's all about understanding how that works, then taking the Bakkavor's portfolio of products and saying, well, where can we make improvements, ranking those improvements, saying, well, yes, if we can make the improvement sources, let's make it there, and really then and take those capabilities so that we can then exploit the technology in as many different markets as we can. And because of the unique environment we're creating, there's also this opportunity to create new products that don't exist, because as soon as you've got uniqueness in the processing environment, you can do different things with different ingredients and treat them in a very different way to how you do traditionally. So the uniqueness comes from the steam, and by accelerating that steam into the product, we are able to heat, mix, and actually pump liquids with and without particulates at the same time. So the vacuum unit sits within a tank in sort of a vessel, or it can sit in the line of the pipe work. And the interest is because when you do these three things simultaneously, you can then reduce the number of processing stages if you're having a process. And when the way it operates, it's a much more effective way of heating and mixing liquids. So there's a white paper link there that I assume I'll be able to share after, which basically just shows how much more effective it is than heating it with a steam jacket or a traditional steam injector. And it comes down to we can get more steam into a product than sort of traditionally without damaging it. So what we do is you can see at point number 1 there, we're taking 6 bar steam in, and we're conditioning it in special chambers to accelerate it to 1,000 meters a second. That means that then it hits, when it hits that liquid in that chamber at point 2, it's actually creating a droplet phase, which then is actually in a partial vacuum. So you're generating a partial vacuum within the chamber. Now, significantly, 6 bar steam is about 190 degrees C. In a partial vacuum, the actual temperature drops to below 100 degrees C. So you've got then this peculiar, very strange effect, actually, where you can't burn products because the steam isn't hot enough. Now, the effect of also hitting steam in at 1,000 meters a second is you get this very strong mixing effect. And you can then reduce that down and sort of bubble the steam back in and have a much more gentle processing. So that's a sort of, the steam then recondenses into the product and it's on and away. And that's what is very interesting. Yeah, that's where basically all the research is being focused on in that technology. So there's been a lot of successful applications then using this heating and mixing. So once you start heating and mixing things up, if we go back to that traditional diagram, you can imagine then we create a bottleneck further down, because if we're not hot filling, we're cooling it, then we're going to have a big challenge cooling. So this is where our second Innovate UK project, which is starting now, looking at cryogenic cooling, so using liquid nitrogen on products to just chill them down much more effectively. Now, there's 2 aspects to this. That at the moment, cooling technologies are quite limited. So they're not overly efficient, so there's a big sort of efficiency gains to be made on the cost side of things. But from a product quality perspective, when you start to chill things and take the heat out of product a lot quicker, then you reduce the thermal damage that's occurring. So if it takes me an hour to chill a ton of sauce, then if I can cut that right down, then I can really limit the amount of damage that I'm doing to those ingredients over time, with some big benefits to be had. So when you then start to apply this is actual data from a soup system that we put in, showing the different phases. And it's for the soup, which is probably argued the leading brand of soup for one of the own label retailers of best quality. When we use our steam infusion, then we can cut that processing time down, and then you're getting some potential product benefits with that as well. But then when you start to look at this, you're thinking it's still taking quite a long time. And then at the same time, there are quite a few quite big challenges that when we start to look at that production line as an incremental change. So how can we apply heating, make it better? How can we cool things better? There's still a lot of complexity that you could argue is actually quite unnecessary. So we have this concept of one pot to rule them all, really, where we'll have a homogenizer, we'll have heating elements, we'll have all our devices that we need to make a product on one pot. Now, this means that when we've got our expensive homogenizer there, that the utilization of that is way below what you'd really want it to be. At the same time, you've got this masses of pipe work, and you've got complicated valves and pumping networks, which isn't very good for product quality, and it's also not good for waste, because product gets caught up in the pipe works, and you start to see yield losses of between 5 and 10%, and that's been corroborated with our customers around the yield losses in that area. And there's also issues of traceability, and what it's really dying out for is a bit of disruptive change. So how can we take those ideas from automotive and say, what could we do differently? So when we think about how we prepare food products in the development of kitchen, there is always a compromise then when you take that to a food production line about how can we manufacture that that product on an industrial scale. And so we don't want to have that compromise. And so if we blue skied and say, well, what if we could do it differently? Well, it would be fully flexible. We would be able to change in technologies, and we'll be able to make a whole range of different products very easily. It would also be modular so that you can take things out, move it to different sites. You can't do that with traditional systems. It would also be unmanned. Would it be unmanned? Yeah? Yeah, we'll go unmanned. So this is a video we've come up with a new concept for. Did we get a sound? Oh, sorry. Is that as loud as it will go?
Yeah, switch on the right hand side, I think, with the display there.
So what if you could make better looking, tastier, healthier food? Solve these opportunities with OAL Flexible Manufacturing. With unlimited process configurations, we can heat, mix, homogenize, combine, and fill. Unprecedented flexibility means you can respond to the ever-changing food landscape, protecting your significant investment. But that's just the start. Flexible manufacturing from OAL means no people, no platforms, no pipework, no problems. Find out more.
So it's quite radical what we're saying here, but the effects are absolutely amazing when you actually then apply that to real life examples. And we know we've got a very good understanding of how things are traditionally made. So then when you start to take these concepts, it becomes very, very exciting. So what effectively we're able to do is by taking robots that are proven and tested in car manufacturing and then apply them to the food manufacturing side of things, we can actually then start to process batches and return to a much more batch-based system as opposed to continuous, but we can process them in parallel. So what we can see here is that same soup production, but we're processing with our April system. Now, as you can see, we just go through the stages, but our homogenizer is always in use because we're transferring the batch and we're not using that, we're able to move that technology around because we've got a robot controlling everything. And so when we've got in trying to bring in these concepts of food manufacturing 4.0 and the Internet of Things, these styles of systems are much more suited to this Internet of Things and the connected manufacturing because they can adapt in real time. They are flexible, whereas traditional manufacturing has its major limitations. So what does this all mean? In terms of material process flows, it'll be like when the Industrial Revolution started or really came to fruition, where factories remodeled around the ingredients and processes going through. This will be really flipped on its head a bit around how the robot can process that. You'll be able to respond to demand much more effectively, and you'll see big jumps in yield. So in terms of the bottom line, our estimations at the moment are showing that on a chilled food plant, we can improve the bottom line by about 15% through these yield benefits and alike. And I think from the food sciences aspect, it's this ability to emulate a chef. So being able to do exactly what you do in a lab in a food processing environment that's very interesting. So it's coming to life. The system is going to be installed at the National Centre for Food Manufacturing. Now that's over in Hull Beach, and it's part of the University of Lincoln. That's going to be ready early 2016. And we've got one of the first system is gone to board approval for a customer over in Dubai. Now, on a final note, this is all then part of a Food is Life open innovation platform that we've started with the University of Lincoln. It's about taking concepts like these and really develop them and trying to improve food production with disruptive change. So if anyone wants to talk about collaborative research, or opportunities there. Those are my details.
Thank you. We have a couple of moments to take questions. Right.
Jake, just a quick question about disruption. Obviously, a lot of food manufacturers already have investment in kit and factories and all that sort of stuff. Do you think there's opportunities here for people who are completely new to come in and start from scratch, because they won't have that they won't have all this stuff basically to get rid of, and they'll be coming in with new mindset, complete new funding, new kit, everything?
Yeah, I think the real driver will be this: when your competitor builds a factory using these principles, and it is undercutting you on price. And at the same time, then it gives you the opportunity for new entrants that are thinking very differently. So the likes of Amazon Prime, not Amazon Fresh, then they can take these models, because it's much more of a logistics challenge then, as opposed to having to have
I was attracted by you're talking about Google and coming into driverless cars. I mean, they're coming from a completely different place.
Yeah.
And, I can imagine that people will be coming from a completely different place and taking this, and they don't have that baggage, that legacy baggage with them.
Yeah.
It'd be very interesting.
Hi, I was just going to ask, what are the costs make up? What's the cost like compared to a traditional factory?
It'd be cheaper.
Cheaper?
Cheaper.
Wow. And then the other question I was going to have, sorry, 2 questions. Have you thought about the packing lines as well? So if you've got food manufacturing going on, is there anything revolutionary we could do for the packing
I think
line?
on the packaging side, robotics is being used quite a lot already in terms of pick and place and associated. So, and I think because it is quite a discrete area, that it's much more suited to this. Whereas if you try to then apply robotics in an incremental way on a processing line, you trap, because you've got so much natural infrastructure that's already there.
Okay.
Okay, one last question from you, and then we'll move on to the last couple.
Thanks. Hi, it's actually 2 quick ones. One, a scientific one. When you've got the steam infusion in there and you've got this tripartite process going on where you're mixing and doing all sorts of things simultaneously, does that still allow for particle integrity? Can you maintain the shape and form of the pieces in there?
Yeah, effectively, if we were cooking a meat mix with big chunks of meat, then what we would do is, when we're creating that base slurry, we'd be using it at a high shear mode, so about 6 bar steam. But then when we're adding those meat particulates, we're cutting the steam pressure right down, so that then it effectively just passes straight through. It's quite miraculous when you can see how powerful it can be, but that it can then process quite gently.
Okay, and then lastly, if I put my shop steward hat on, what about all the jobs that the April system's going to cost? When you take all the people out of your factory. Have you thought about that one?
Obviously, there is a major skills challenge in the food industry, and it does create more highly skilled jobs, as it has done in the automotive industry, the adoption of robotics.
Cool.
Cool.
Thank you.